Hi, this is Eddy Prieto in Lab Group MO4 for Physics 1 at Georgia Tech. This is our last at-home lab, Lab 11, a free topic in which I chose to see if a steel ball being dropped on an anvil is considered a perfectly elastic collision. In lecture, when Dr. Greco showed this example, I was interested in seeing how it worked, so I decided to model it. Now, the problem is a steel ball bouncing on an anvil a perfectly elastic collision? And the main result was that I found that while a steel ball bouncing is an elastic collision, it is not a perfectly elastic collision. Now, some relevant models. An elastic collision by definition is an ideal collision in which there is no change in internal energy. For perfectly elastic collisions, there cannot be any change in kinetic energy and momentum is conserved throughout the entire collision. Now, let's go to the tracker video file. It should look familiar as Dr. Greco showed us this video in lecture. Alright. The man who is filming the video drops a steel ball with a radius of 2.5 inches from a foot above the anvil, and as it bounced, I tracked the ball's path. I then got the data from here in the bottom right corner and put it into a CSV file, and then I imported that data in the VPython. Now this is my VPython code that I have. For my VPython code, I have a ball with the same radius and mass from the experimental data in the video, and I tried to model a perfectly elastic collision as well as I could. But this is just an approximation. So when I run it here, this should give me the values of a perfectly elastic collision. You can see the two balls bouncing. The red is the computational version, while the perfectly elastic bounce, and the blue is the experimental data taken using the YouTube video. You can see that the ball bounces are very similar in pattern, but the experimental ball doesn't bounce to the same height every time. It kind of decreases a little bit, and that is why it is not a perfectly elastic bounce. It's like the computational model, where it bounced to the same height every time, and it went back and forth perfectly. But the pattern is very close. The balls bounce the same amount of times and in a rhythm together. So it does show that this was in fact an elastic collision. Because the ball did not return to its original height, we know that the velocity was different from before and after the collision. Therefore, if the velocity was different, the kinetic energy must be different. And so that means kinetic energy was not conserved throughout the collision. So that's how we can tell that it is not, in fact, a perfectly elastic collision. And that's it for my Lab 11 at home, in which I modeled a steel ball dropping on an anvil. I hope you guys enjoyed it. Thanks for watching.